Hello students, myself Mr. Kiran S. Chinsolkar, lecturer in Mechanical Engineering Department from Praveen Patel College of Diploma Engineering and Technology. We are starting first chapter, that is Fundamental of Machining and Machining Operations. We are now starting part 3, Learning Outcomes. After you watching this video, you are able to know various lathe operations. Second, various cutting parameters for lathe machine. Various lathe operations. Various operations performed on lathe are: first operation is a facing, second operation is a centering, third operation is a straight or plane turning. This is also divided in a rough turning and finish turning. Fourth operation is step or shoulder turning. Fifth operation taper turning. Sixth operation chamfering. Seventh operation knurling. Eighth operation parting off. Ninth operation drilling. 10th operation reaming. 11th operation boring. And 12th and last operation is thread cutting. Now we studied all operation in details. First operation is a facing. Point 1. Facing is the operation of machining the end of workpiece to produce flat surface perpendicular to the lathe axis. Second point. Facing operation is also used to cut the workpiece to required length. Third point. The work is revolved in the center and facing tool is mounted on the tool post and cross feed is given to tool with help of cross slide. Next operation is the centering. First point, it is the operation of producing conical hole in the workpiece so that it can be held between the chuck or dead center. Second point, for centering operation, a combination of drill or countersink is used. Third point, drill and countersink hole has the same angle as the lathe center so that lathe center fits well into the hole. Fourth point, the standard included angle is 60 for general class work and 75 degree for heavy duty work. You can see from this above diagram, there is a combination of drill and countersink at the top of the diagram, and below this the workpiece is held in the chuck, and right hand side there is a center drill. The center drill drills the hole in the workpiece. Next operation is straight turning or plane turning. First point, straight turning produces a cylindrical surface by removing excess metal from the workpiece. Second point, the cutting tool is rigidly held in the tool post and feed parallel to the lathe axis. That is, longitudinal feed may be given by hand control or power feed. Third point, straight turning may be of following type: rough turning and finish turn. Now we study this straight turning in details. The straight turning is classified as rough turning and finish turning. There are two types of turning. First is a rough turning. Rough turning is done by taking heavy depth of cut and giving high feed rates to reduce machining time. Second point, during rough turning, work is revolved at lower speed and cutting speed is low. Third point, depth of cut varies between 2 to 5 mm and feed rate zero point 0.3 to 1.5 mm per revolution of work to produce rough surface finish. And second turning is a finish turn. After rough turning, we are doing finish turning. Finish turning requires high cutting speed, small feed rate, and small depth of cut. Second point, it gives smooth surface finish. Third point, the depth of cut ranges from zero point 0.5 to 1 mm and feed rate is zero point 0.1 to 0.3 mm per revolution of work. Next operation is step turning or shoulder turning. First point, during this operation, a step or shoulder is produced from one diameter to the other diameter. Second point, different types of shoulder produces are square shoulder, bevel shoulder, radius shoulder and uncut shoulder. In this slide, we can see at the topmost position there is a some different types of shoulder are given. First is a square shoulder, second is a bevel shoulder, third is a radius shoulder, and fourth is a undercut shoulder. This type of shoulder can be produced on the lathe machine. Next operation is a taper turning. But before start the taper turning, we study the taper element. Taper turning is the operation of producing a conical surface of uniform increase or decrease in diameter from a cylinder workpiece. Taper misses may be specified by half taper angle alpha. From left hand side we see the taper element. There is a taper, small diameter T to larger diameter capital T. So for getting angle alpha, there is a formula on right hand side is tan alpha is equal to capital D minus small d divided by 2 into L. So alpha is equal to tan inverse of capital D minus small d divided by 2L. So capital D denotes larger diameter of taper in mm. Small d denotes smaller diameter of taper in mm. L denote length of taper in mm and alpha is half taper angle. For taper operation, we have to calculate first alpha, that is half taper angle. In this picture, we see the taper turning operation. On left hand side, there is shown the 3D view of taper. This type of taper is produced by the taper turning operation. On right hand side, there is a 3D view of taper workpiece. There are most common methods of taper turning are: first is a taper turning by form tool. Second method, taper turning by swiveling compound rays. Third method is taper turning by setting over tailstone. And fourth is taper turning by taper turning attachment. Now we study taper turning operation method. First method is taper turning by form tool. In this diagram we see that there is a chuck. In chuck work is held and below this work there is a form tool with angle alpha. First point in a taper turning by form tool is a form tool having broad nose is used for short external taper turning. Second point, the tool is ground to half taper angle and fed to work perpendicular to the lathe axis to obtain desired taper surface. Third point, it is used for small taper length, that is for chambers, head of screw, etc. Fourth point, the length of taper is limited to width of tool. Taper turning by form tool is an operation which are used for getting different length of taper. By using form tool, we can produce a small taper. That is this taper, application of this taper for chamfers. You can see the head of screw. Head of screw is taper for a small length. Second method for taper turning is taper turning by swirling compound rest. For the above diagram, we can see that on left hand side there is a chuck. In the chuck there is a workpiece hold. Below the chuck, below this workpiece there is a tool and there is a compound rest. And this compound rest is inclined to angle alpha. Alpha is a taper angle. So, in case of taper turning by swirling compound rest, we can keep in mind in the following points. First point, in this method, tool is fed at angle to the axis of rotation of the workpiece. Second point, the tool is mounted on the compound rest. Third point, the cutting edge of the tool is accurately set at the center line of the workpiece. Fourth point, the compound rest has a circular base which is graduated in a degree. It is swelled to half taper angle and clamped. Fifth point, after setting the compound rest at half taper angle, rotation of hand wheel causes the tool to fade at an angular direction, generating corresponding taper on workpiece. In taper turning operation by swirling compound rest, we rotate the compound rest at angle alpha and tool is moved according to the angle setting, and with help of this setting we get taper on the workpiece. Then advantages of taper turning operation with help of swirling compound rest. First advantage, it is useful for short and steep taper. Second point, external as well as internal tapers can be turned. Third point, better surface finish can be obtained than form tool method. Fourth point, very easy setting for a wide range of angle. Now we study disadvantages of this method. First point, only very short and steep taper can be turned about 75 to 100 mm. Second point, length of taper turn is limited to travel of compound rest. Third point, only hand feed is available as there is no power feed for compound rest. Fourth point, hence poor surface finish is obtained. Next method for taper turning by setting over tailstock. This method, taper turning by setting over tailstock, you see in this diagram. Here we attach the workpiece with a setting over tailstock. In this method, first point in this method is the axis of rotation of the workpiece is made inclined at angle equal to half taper angle with the lathe axis by setting the tailstock center. Second point, tool is fed parallel to the axis of the lathe. Third point, setting over tailstock is done by sliding the body of tailstock towards or away from the operator by means of set over screw. Fourth point, the amount of set over is limited, hence method is used for turning small taper on long cylinder job. Actually, this method are used for the long cylinder job. In case of taper turning by swirling compound rest, uh, we move the compound rest at angle alpha and workpiece is rotated with the spindle or the chuck. But in case of setting on tailstock, We move the workpiece or held the workpiece at angle alpha and tool feed parallel to the lathe axis. This is the difference between these two methods. Next operation is a chamfering. First point, chamfering is operation of producing a bevel shape finish at the end of workpiece. Second point, chamfering is done for removing burrs and for protecting the ends from getting damaged. Third point, chamfering is essential after thread cutting operation. Fourth point, it may be performed after turning, knurling, boring, drilling, etc. Next operation is knurling. In above diagram, we see the knurling operation. The work is held between the chucks and with help of knurling tool, we are doing knurling operation. On right hand side, we can see the 3D view of knurling operation. Now we see the knurling operation. How to perform? First point, knurling is the operation of producing a diamond shaped pattern on the surface of the workpiece. Second point, the purpose of knurling is to provide an effective gripping surface on a workpiece to prevent it from slipping when operated by hand. Third point, knurling is provided on the handle of the machine and gauges. Students, you see the various type of gauges, micrometers. On these handles, there is a knurling operation is done for gripping purpose. So the main idea behind the knurling operation is to get the diamond shape pattern on the workpiece for easily gripping. Next operation is parting off. We can see in above diagram there is a work is held in our chuck and with help of parting tool we perform this operation. The first point in parting operation is parting off is the operation of cutting workpiece after it has been machined to the desired shape and size. Second point, in this operation, workpiece is rotated at half the speed that of the turning and narrow parting of tool is fed perpendicular to the lathe axis by rotating cross-slide hand wheel. Third point, the carriage is locked at particular position before start of the operation. So main idea behind the parting off is we cut the workpiece at a desired length. Next operation is drilling. In above picture we can see the drilling operation. The work is held in a chuck and the drill is held in a tailstock and with help of tailstock we feed the drill inside the workpiece. So we are studying drilling operation in details. The first point, drilling is an operation of producing a cylindrical hole by removing metal by the rotating edge of the cutting tool called as a drill. Second point, the workpiece is held in chuck and drill tool is fitted in a tailstock barrel. Third point, the drill is fed to workpiece by rotating handwheel of tailstock. Fourth point, the speed and feed of a drilling operation is 25% lower than the normal speed and feed used on drilling machine. Next operation is reaming. You can see the reaming operation in above picture. On left hand side is the actual picture and right hand side there is a 3D picture. So, rimming operation. First point, rimming is the operation of finishing and sizing a hole which has been previously drilled or bored. Second point, multi-point tool known as rimmer is used for operation rimming. Third point, the rimmer is held in a tailstock and fed by rotating handmill of tailstock. Fourth point, the workpiece is rotated at slow speed. The speed varies from 0.5 mm to 10 mm per revolution. So, difference between drilling and rigging is that in drilling we are originate the hole, but in case of rigging we are finishing this hole with help of tool called as a rimmer. So there is a difference between rimmer and drilling. Next operation is boring. So boring is the operation of enlarging or truing the holes produced by drilling, casting, forging, etc. Second point, boring cannot originate hole. Third point, the work viewers in a chuck and boring bar is fitted on post which is feed longitudinally. Fourth point, the feed of tool is given by cross feed of carriage. In case of boring, we have already discussed that boring is not cannot originate hole. So boring is an operation for enlarging the hole, just previously did by drilling operation. Next operation is a thread cutting. Thread cutting is one of the most important operation performed on lathe. We can see in this diagram at upper side there is a headstock spindle. The workpiece is held between the two centers headstock and tailstock. After that at left hand side there is a changes gear and bottom there is a lead screw with a carriage and at the middle there is a tool post. So in case of thread cutting, internal as well as external threads can be cut on the lathe with help of threading tool or with the help of tap and die respectively. While cutting thread with help of cutting tool, the following requirements are to be fulfilled. First point, there should be certain relation between workpiece revolution and revolution of lead screw to control linear movement of the tool parallel to the workpiece when the nut is engaged with the lead screw. Second point, the tool should be finished to proper shape to the thread to be cut. Next point, the principle of thread cutting is to produce a helical groove on a cylindrical surface. The tool is fed longitudinally against the workpiece, which is rotated at slow speed between the centers or by a chuck. The longitudinal feed of the tool must be equal to the pitch of threads to be cut per revolution of the workpiece. The workpiece rotates while the lathe axis slowly with help of back gears. The lead screw shaft is connected to the lead screw and the spindle through the changes gear and the movement of the tool with the carriage is obtained by half nut mechanism. A definite ratio between the tool feed and rotation of the headstock spindle is obtained by selecting the change gear of required size. So, in case of thread cutting, there is some relation between workpiece rotated and lead screw. With help of this and help of some calculation, we are setting the gears and moment of the tool post. Now we study cutting parameters for lathe. First parameter is cutting speed, which is denoted by capital V. So cutting speed is defined as the speed at which the metal is removed by a tool from the work. Second point, in other words, it is the surface speed of the work against the cutting tool. Third point, it is expressed in a meter per minute. Fourth point, In lathe work, cutting speed is given by relation V is equal to pi d8 divided by 1000 and unit is meter per minute, where D is the diameter of work in mm and capital N is equal to RPM of work. Now we study factor considered for selection of cutting speed in the lathe machines are first factor is material of the cutting tool. Then second, hardness and machinability of the metal to be machined. Third point, quality of heat treatment if it is steel tool. Fourth point, whether machining is to be done with or without the use of coolant. Fifth point, rigidity of tool and the work. Sixth point, shape of the tool. 7. Depth of cut. And 8. Fit to be given the tool. Second parameter is feed and it is denoted by small f. The first point in feed is the moment of tool relative to the work is termed as feed. It is second point, it is expressed in mm per revolution. Third point, machining time can be reduced by increasing the feed, but it reduces the tool life. Lathe work may be have three types of feed. First feed is a longitudinal feed. When tool moves parallel to the lathe axis, the feed is termed an longitudinal feed. Second, it is obtained by the moment of carriage in the lathe work. Example of longitudinal feed is plane turning operation. Next feed is cross feed. When tool moves perpendicular to the lathe axis, it is called as a cross feed. It is obtained with help of cross slide in the lathe. Example of cross feed is facing operation. Third feed is angular feed. When tool move at angle with the help of compound slide, it is termed as angular feed. Example for angular feed is staple turning operation. Next cutting parameter for lathe is depth of cut. It is denoted by small d. First point, depth of cut is the thickness of material removed in one revolution. Second point, it is measured in a direction perpendicular to the machine surface. Depth of cut is always perpendicular to the direction of the feed. Depth of cut is given as depth of cut small t is equal to d1 minus d2 divided by 2, where d1 is the diameter of work before machining and d2 is the diameter of work after machining. Next parameter is machining time. It is denoted by capital Tm, small m. The machining time can be calculated if the speed of job and length of job is known. Machining time can be given as Tm is equal to L upon N into F and its unit is minute, where L is equal to length of travel of tool on a job in mm, capital L is equal to RPM of work and small f is equal to rate of feed in mm per revolution. I hope you understand this presentation. Thank you.